Coming then to the other end of the firebox, into the firebox backplate, we can see that here we've got the hole for the fire where you put your coal into, and here the stays are marked up in this plate to give it strength. Because it's a flat plate, it would have no strength against boiler pressure, so it needs to be tied with the stays into another plate which is quite close to it. So here again we're looking at the plate as a face, and here we're looking at the plate on end, and this basically is what we're looking at, just this shape here. Again we can see that we're looking at this face of it, because we can see that these two lines are solid lines, so we're looking at this. If we were looking at that side of this particular plate, this inner line would again be broken, and it isn't. Again, this is another case where the dimensions are not on the drawing. Some of the dimensions are missing. We can see that this radius is marked up for us to come back to a centre point and do that radius. These radiuses on the corner are again tight, and in our boiler's case will actually match the same radius as the other plate that we've just looked at, the firebox tube plate. And then moving back to the extreme end of the boiler again, this is the last plate, this is the backhead plate, and here we see the measurements for the spacing of these stay holes, which don't appear on this drawing here. But we know that this plate is almost a copy of that plate, and these are the same stay holes as they are here. So again, we know that if the dimensions are not on the plate that we're looking at, we need to go to another part of the drawing and we will find them dimensions. This being the back plate, we've got some bushes on here. Again, it's telling us that whatever that dimension is that's under there, it's by 26 threads per inch. This one also 26 threads per inch. These here are 40 threads per inch. And again 40 threads per inch. And these bushes give the backhead strength, because again it's a flat plate, the bushes etc. and the stays going through give this plate strength so that it doesn't buckle against the steam pressure inside. That's these stays and these bushes all giving it strength. Here's where you put your coal through the fire hole door, as it is there. And between this plate and this plate, there is a small ring that goes between the two, because these plates are approximately ½ inch apart or something like that. They placed one on top of the other, like that. They go quite close together, like that, and the stays will go between the two, and the round ring would go through the two again, where you would put your coal. This piece here is an added on piece that gets soldered onto the end, or should I say the radius of this boiler plate here, and it's got to be in line with this one here, because there goes your sight glass. You have a clear glass between there and there, which shows you your water level, and your water level must never drop below the crown of your firebox. So this piece here would be slightly down here. If we look at this hole here, we know that all of this moves down and over the top of that. And this here, when you've got your glass in there, you would never let your water level drop below this point here, because it would expose this crown here to direct fire that's inside it, and this copper would tend to melt and burn a hole in it. But if it's got water over the top of it, it would just boil the water, and the water would dissipate the heat, thereby protecting this piece of copper. So this is a very important piece, and if you don't get these just in line, the glass, when you tighten the unions onto the glass will break. Again, because this line is broken, this inner line is broken, we know we're looking at this side of this plate and not that side, because again, the flange would be shown up in its thickness, but we can't see its thickness because we can't see the flange. The flange is hidden in this case. And again, this piece here is what we've got there. That's the drawing of it there. And this is showing us these bushes, the position of them coming through the plate. So this is the thickness of the copper, 1/8 of an inch copper, and this bush is coming through it. These dimensions here give us the diameter of it, and these dimensions here would give us the length of the bushes, etc. So that's where you pick your dimensions up from. And on the top of this wrapper then, here, would be what we call the crown stay, and they would stop the steam pressure collapsing these pieces in on the flat plate that would go on top of there, because these are close together, but further along the boiler there's a space between. We'll look at that in a moment. But first let's have a look at the crown stays. So this then is the part of the drawing that deals with these crown stays, or the girder stays over the top of this firebox area here. As we look at it, we can see that it's compiled of 6 parts in actual fact. That being 1, that being 2, 3, 4, and this area here, there are 2 of them, so that's 5 and 6. We'll have a look how that fits together very shortly. And these fit over the crown of the firebox and over its full length. So this is the shape of it, with several holes drilled through it such that water can flow through and get nicely warmed up throughout the whole of this area here. The holes are in there, so the water would just flow through wherever it wanted to go in that area and create steam. And the steam would be gathered from the very top of the boiler in this steam dome arrangement here, which is down the length of the boiler, about the middle of the boiler barrel. So the idea of this stay that we can see here is that it doesn't allow this section of the firebox wrapper to get pushed down with the steam pressure that's built up in this area here. So these would be like the parts that it was made from. And again, it's just 1/8 inch copper. There are 4 of them. Here I'm just showing where the holes are drilled through, and they would fit back to back with this scallop shape on. I've omitted it on this piece here, but they just fit back to back like that, and that's what they do. So I'll just stick those together, and then we can see what this arrangement actually looks like in reality. So with CAD technology then, cardboard aided design, we can see that that is what we're looking at. And if we move that across to there, we're looking at it over there. So that's the stays, the girder stay that fits on top of this wrapper that we can see here. So I'll fasten a few more of these bits and pieces of cardboard that I've put together, and we'll show you what we're actually looking at on this drawing here then. So here now would be the inner firebox, as it would be called. This would be the inner firebox wrapper, and that would just be a sheet of copper bent over around these previous bits that we saw. So that would resemble that piece there, and here we have the stay arrangement that would fit on top of that. So that would be that piece over there. So there's really nothing too frightening about making a boiler, as we can see. I'll just put together now the other part of the outer wrapper, and then we'll see where these stays, or should I say where these stays here would go through. And again, the stays would go through here, because this would be the backhead. That would go on there, and these stays here would tie these two flat plates together to stop them buckling, as steam pressure would be inside this area here. So this then would be the outer wrapper, and the inner firebox would simply sit inside like that. And as I explained earlier, this is what the water space and steam space. And the stays would go between these two plates, tying them together so they don't belly out like this. So lots of stays, silver soldered through holes, just to hold it together, to stop them splaying apart like that. And these crown stays would be inside of there effectively. And of course on one side here we would have the tube of the boiler. Of course on one side there we'd have the tube of the boiler going forward with a second finishing plate just at the bottom here, which I'll show you just now. Again, that would be no more than a piece of copper filed up or cut to the shape of the boiler barrel at the bottom and fitted there in that position. And again, these would be the stay positions holding these two together to stop these flat plates bursting apart the boiler tubes would hold the rest of this face from collapsing and bowing and buckling under the pressure of the steam. So I hope that's just given you some insight as to what's happening with this boiler and what each of these components are and where they fit within the integrity of the boiler construction. Here we have what's called the foundation ring, and this is just a square piece or oblong piece of copper spacing these two plates apart and filling in the bottom. And there it goes on its dotted line, because we can't see it, it's inside the boiler, but there it is. It goes along there, and that's it there. That's the foundation ring, and that has a square section there to keep these plates apart and an oblong section to keep these wider plates apart. And that would fit in this section round here, all the way around here. That's where the foundation ring would fit. So there we are. I hope this presentation of the layout of the plan and how to use the plan and apply the dimensions and the like and the drawing technique to the plans, and I hope this encourages some people to have a go at building a boiler themselves. So there's a brief overview of everything. Let's see how I get on with mine. So armed with the drawings then, and a copy of the builder's notes from the designer of the model that we're talking about, complete with boiler instructions, all in this pad here. And we also have the Martin Evans book of boiler building, which again will relate in many aspects to this particular locomotive, being as he designed the boiler for it. And this talks predominantly about a build in propane gas, using propane torches, doing the silver soldering, etc. I've also got this book by Alec Farmer, and this book predominantly is talking with respect to oxy-acetylene heating sources for making the boiler. And of course we've got YouTube. So with all these in mind, and YouTube, and the Model Railway Club where I'm a member of, I've got a gentleman down there that's leading me along with this boiler, so that's fantastic. So with all those things in place then, let's try and get cracked on and have a go at making this boiler as a novice and see how we go on.